I want to talk about lesson 8, especially because we've got an exam next week. So please make sure you watch this video and also watch the videos on my open math. Okay. All right. So here we are going to talk about rational functions, and we are going to look at domain, vertical asymptotes, and horizontal asymptotes. We would also talk about the LCM and LCD, and then simplifying and adding or subtracting rational functions. And then we're going to talk about more operations of rational equations, rational functions, and then we solve rational equations. All right. So first of all, let's look at the characteristics of rational functions. So for a rational function, we know that we are going to have this general form f of x equals p of x divided by q of x. And remember that in lesson 7 we did use p of x a lot. Okay, and these are representations of some functions. So p of x divided by q of x. And p of x and q of x are polynomials. Q of x must not equal 0, because if it equals 0, then the numerator p of x divided by 0, that is going to be undefined. So that is one thing you should always remember. Because of that, the domain of a rational function is going to be the solution found when solving q of x equals 0. When you solve q of x equals 0, whatever you get is not going to be part of the domain of f of x. Why? Because we just talked about the fact that q of x must not equal 0. Okay, q of x must not equal 0. So let's say that we've got, let me go to the whiteboard. We have f of x equals 7x divided by 4x minus 3. Now, if you have this, we know that this denominator should not equal 0, because at any point if it equals 0, the rational function is going to be undefined. So you don't want that. Okay, now the domain here is going to be, so here we have, remember, p of x, over q of x. The domain 4 of x minus 3 equals 0. Now if we solve for this, we have 4 of x equals 3. You divide by 4, you divide by 4. So x equals 3 over 4. What does this mean? It means domain is all real numbers except x equals 3 over 4. Because when x equals 3 over 4, q of x equals 0. And you don't want q of x being equal to 0. So it is one thing that you should always remember. You don't want q of x being equal to 0. So that gives you your domain. That gives you your domain. All right. Now, what about the asymptotes? The asymptotes. So we have vertical and horizontal asymptotes. Now, the asymptotes, what is that? Sometimes you might have a graph where this is possible. With an asymptote, you are looking at, I'll show you one graph like that. You are looking at something like that. If you look at this, the red line, which is x equals minus 3, the red line, you can clearly see that the graph is approaching the red line, but it's never going to touch it. It's approaching the red line, but it's never going to touch it. When that happens, we say that the red line is the vertical, because it's a vertical line. The red line is the vertical asymptote, because the graph gets close to it, but it's never going to touch it or intersect it or cut through it. It's never going to touch it. Now, for the horizontal asymptote here, the horizontal is the x-axis, or y equals 0. So you could see that for the x-axis again, the graph is never going to touch it. It's going to get close enough, but it's never going to touch it. Okay, so that is the asymptote, the line that the graph gets so close to but never touches it. And we've got two, vertical and then horizontal. All right. So to find the vertical asymptote, the red line, which I just showed you, to find that, you have to go to the function and then look at q of x equals 0. Q of x equals 0. That is the denominator part. Okay. Now, if you solve that, whatever you get for your solution of x, that becomes your vertical asymptote. So q of x equals 0. Solve that. Whatever you get is your vertical asymptote. Okay, that becomes your vertical asymptote. So it could be x equals -3, x equals +2, or whatever it is. Now, what about the horizontal? Now, the horizontal, there are some cases that you should always remember. For the three cases, the first one is that you go to the rational function, okay? You go to the rational function, and then you are going to find the greatest degree term in the numerator and then the denominator. The greatest degree term, let's say that if I have, or let me go to one of these problems. So, if you look at the problem, we have 2 divided by x plus 3. 2 divided by x plus 3. Now, you have this 2 divided by x plus 3. Now, the greatest degree term in the numerator is going to be 2. The greatest degree term in the denominator, remember 3 here, you've got x to the power 0 attached to it. And x here is x to the power 1, right? X to the power 0 is 1, so you don't write that. That's why we got 3. Okay? And here you could still have x to the power 0. So for the numerator, the greatest degree term is going to be 2 because it's just 2. And then the denominator is going to be what? X. You have 2 over x. Alright? Anytime you have this, a number divided by an x, like that, anytime you have this, now the horizontal asymptote is going to be y equals 0. Now, what about if you have, oops, let me do that again. 2 over x plus 3. So you're going to have x to the power 0, x to the power 1, x to the power 0. So this is going to give us 2 over x, like that. So y equals 0. Okay, that is the x-axis. Now, what about if you have 4x divided by x plus 2? So here, for the numerator, the greatest degree term is what? 4x. For the denominator, the greatest degree term is x. Why? Because we've got 2 here, but it's got x to the power 0. So this can cancel out to its lowest term. Oh no, this thing has a big problem. You want to, okay, let me do it again. So I have 4x divided by x plus 2, like that. And then we had 4x over x. So to its lowest degree, this cancels out. So you have 1, 1, so you have 4, right? So since you have this, your horizontal asymptote is y equals 4. Okay, y equals 4, like that. All right, so let's go back to then let me talk about the case 3. Now, for the second case, you would see that a number over x, okay, a number over x, sometimes you might have 2x over 3x squared plus 4. Now, the greatest degree term on top is 2x. The greatest degree term at the bottom is 3x squared. Now, to simplify this to its lowest term, x would cancel x to get an x. So I'm going to cancel the square. So we have 2 over 3x, right? You got 2 over 3x. Because you've got a number over an x term, you know that that is going to go to a 0. Once you have,
I don't understand. Okay, I found this on the web for Hey Siri, why do you have a number why don't you have? Check it out.
okay, sorry about that. So if you have a number over a variable, okay, you're always going to have y equals 0. So that tells you that the degree of the top, the degree of the top is lower than the degree at the bottom. Like this, you have x and then x squared at the bottom, right? X and then x squared at the bottom. So that should always give you a 0. But for case 3, what about if we have something like this? 3x squared over 2x. Now, the greatest degree is 3x squared, and then at the top is 3x squared, and then the bottom is 2x. So you would see that at the top we have a squared, at the bottom we have only x. When this happens, then we are going to say that our horizontal asymptote is undefined. It's undefined. And that happens is undefined. Okay? So 3 options we've talked about. Now let's go look at some problems. Now, let's work the example. Remember, we have f of x equals 2 divided by x plus 3. 2 divided by x plus 3. Now, to find the vertical asymptote, that is x, remember, plus 3 equals 0. That is q of x should equal 0. You solve for that. X equals what? Negative 3. So that becomes vertical asymptote. So that's what we have here. Okay, that's the red line. It's x equals negative 3. So you can see that at this point, x is what? Negative 3. Okay. Now, for the domain again, because the domain is that you have to solve x plus 3 equals 0. We already solved that. Okay, we already solved that. So the domain is going to be all real numbers except negative 3. So the way you find the domain is the same way you find the vertical asymptotes, only that x equals negative 3 is not part of the domain. X equals negative 3 is the vertical asymptote. Now for the horizontal, you go to the numerator, you find the greatest degree, which here is 2. And then for the bottom, the greatest degree, that is with an x, is x. A number over the variable gives you y equals what? 0. Y equals 0 as the horizontal asymptote. All right, let's keep going. So this is a media example, so I would let you go and then watch the video. Go and watch the video for that. Now, what about this one? The U-try problems. The U-try problems. So for the U-try problem, it says you draw the graph, that is with a calculator, and then you find the domain. So first of all, let's find the domain. X minus 5 equals 0. So you move this here, you have x equals 5. So domain x equals 5. Domain is all real numbers, except what? X equals 5. Because when x equals 5, the function is going to be undefined, right? If x equals 5, 4 minus 5 minus 5, this is the x. That gives you 4 over 0, which is undefined. So you don't want this. So domain is all real numbers except that. Now, because we have x equals 5 here, we know that is going to be the vertical asymptote. X equals 5. And what about the horizontal asymptotes? What about the horizontal asymptotes? So that we would have to find. So to find that, maybe you should try it before I do it. To find that, you go to the top, and then on the top, the greatest degree is 4. You put a 4 there. At the bottom, the greatest degree is x. So we have 4 over x. So what does that tell us? A number over the x, or the variable, that means y equals 0. So this is not difficult. You only have to remember the rules. You only have to remember the rules. What about this one? B. What is the domain going to be? 2x plus 1 equals 0. You move this to the other side, it turns to -1. 2x equals -1. You divide by 2, divide by 2. So x equals -1 over 2. So for the domain, x equals all real numbers except x equals -1 over 2, or -1/2. Now, since we have this, that is going to be our vertical asymptote. The vertical asymptote. Okay, that is going to be our vertical asymptote. Now, what about the horizontal asymptote for this one? What about the horizontal asymptote? So the greatest degree with the numerator is going to be 3x, and then the bottom is 2x. Simplify it, x would cancel x, so we have 3 over 2. So y equals 3 over 2. That is our horizontal asymptote. Our horizontal asymptote. And then what about the third one? The third one, we've got 2x plus 1 divided by 4 minus x. What is the domain? 4 minus x equals 0. Because I've got a minus x, I could move that here. I have 4 equals x, or x equals 4. It's the same thing. So it is all real numbers except x equals 4. Since we have x equals 4, that becomes our vertical asymptote. X equals 4. All right. Now, what about our horizontal asymptotes? What about our horizontal asymptotes? So for the horizontal asymptotes, we are going to have, for the top, we have 2x. And then for the bottom, we have minus x. So simplify it, x will cancel x, so we have 1 here. So 2 over -1 gives you what? -2. Right? So y equals, because we have a number, y equals -2. Y equals -2. All right, let's keep going back to our file. All right. Now, let's talk about the LCM, or the least common multiple, or the least common denominator, okay, and adding and subtracting rational functions. Let's look at those. A rational function is simplified or reduced if the GC of the greatest common factor, we talked about greatest common factor previous, of the numerator and denominator is 1. We can reduce a rational function by factoring the numerator and denominator and then cancelling any common factors between numerator and denominator. So look at the problem 4. Look at the problem 4. So with problem 4, we've got x squared minus 9. That is a difference of 2 squared, right? If you remember that, a difference of 2 squared. And then we have 5x plus 15. Because the numerator x squared minus 9 is a difference of 2 squared, we know that we're going to have x plus 3, x minus 3 divided by. Now, what about 5x plus 15? 5x plus 15, we could bring the 5 out and we have x plus 3, right? We did that previously. So you can clearly see that x plus 3 would cancel x plus 3. So in the end, we're going to have this. Okay, x plus 3 will cancel x plus 3. All right. Now, problem 5 is a media example, so I'm going to skip that. And then we're going to move on. Okay, we're going to skip that and we are going to move on. Oops. All right. So let's look at problem 6. Yeah, problem 6. Problem 6. So problem 6 here, we are going to have x plus 1 divided by x squared plus 2x. Okay, let me go to the whiteboard and then do it there. So we have x plus 1 and then x squared plus 2x plus 1. So x plus 1, that there is nothing you could do about it. But what about the quadratic here? This guy. Yes, we could do something about it. We can factorize that. Now, if we do x squared plus 2x plus 1. So to factorize that, we know that 1 times 1 gives 1. So we need two numbers that multiply to give you 1. We need two numbers that would add to give you 1. This is 1, 1. 1 times 1 is 1. 1 plus 1 is 2. So this gives us x squared plus x plus x plus 1. So x out, x plus 1, plus 1 out, x plus 1. So x plus 1, x plus 1. So this gives us x plus 1 over x plus 1, x plus 1. So we're going to have 1 over x plus 1, like that. Okay, all right. So we've simplified this rational function. We've simplified that. So kind of like you think about how you could factorize the numerator or the denominator and check if something would cancel out. All right. Now let's look at problem 7. So with problem 7, we've got 2x at the top over x squared plus 2x. So this could be 2x, the x. So I'm bringing x out. I have x plus what? 2, right? And check to make sure if it's right. Times x is x squared. X times 2 is 2x, okay? So now I've got 2x over x plus 2. So 2x and x would cancel x here. So I have 2 over x plus what? 2. And that's it. That's all you could do. That's all you could do. 2 for x plus 2. All right. Now let's talk about LCM for a little bit. So for lowest common multiple, we are looking at multiples. Okay, we are looking at multiples. For example, the LCM of 2 and 3. The LCM of 2 and 3, we have 2. So we find multiples of 2. 2 times 1 is 2. 2 times 2 is 4, 6, 8, 10, 12, and then you keep going like that. Okay. The multiples of 3, you have 3 times 1 is 3, 6, 9, 12, 15, 18, and then you keep going. Now we're trying to find the lowest. It has to be common multiple. So 2 is here, 2 is here, 2 is not here, 4, no, 6 and 6. Oh yeah, 6 and 6. So that is the lowest common multiple. It's common, but it's the lowest. Okay. So that's how you find these. Now there is another way to find the LCM, and it's called the prime factorization method. If you want to use the prime factorization method, that's fine. But I would always suggest the first one, what I just did for you. I would suggest this for you because that is very quick. Okay. All right. So I'm going to go over the prime factorization real quick. So using the prime factorization, let's say we are looking for the LCM of 10 and 21. So you look for prime factors of each of the numbers, that is 10 and 21 in this case, 10 and 21 in this case. Now, a prime factor, a factor is a number that would go into the number we are looking at, okay, evenly, to go into it evenly without a remainder. So if we pick 10, oops, we pick 10, the factors of 10 is 1, because 1 will go into 10, right, 10 times. 2 will go into 10, 5 will go into 10, 2 times. Then we've got 10 will go into 10. These are the factors of 10. But what about prime factors? In fact, what about a prime number? A prime number is a number that has only two factors. Only two factors. 1 and then that number itself. So a prime number, if you look within this, a prime number has only two factors. So 10 itself is not a prime number because it's got 4 factors. What about 1? 1 is not a prime number because it only has 1 factor. What about 2? 2 has 2 factors. What are the factors of 2? 1 will go into 2 and then 2. 1 and then the number itself. So the factors of 2 is 1 and 2. So 2 is a prime number. What about 5? 5 has only 2 factors, 1 and 5. So 5 is a prime number. What about 10? 10 is not a prime number because we have it right here. So the prime numbers or the prime factors of 10 is 2 and 5. And that is why we have it here, 2 and 5. Okay? And what about 21? So when we go into 21, first of all, we think about the factors of 21. We have 1, 3, 7, 21. And these two are the prime factors. They are prime numbers and also factors of 21. So 3 and 7. Okay, 3 and 7. Now, we have to pick these prime factors of these two numbers and then multiply the distinct factors with a prime base. Okay, and the highest power or exponent of each factor between 10 and 21 to find the LCM. What does that mean? So if I go to 10, I know these are the prime factors, 2 and 5. And that's all I have, 2 and 5. So I pick 2. and then I pick 5 because they all have the highest power, which is 1. I come to 21, I have 3 and 7. They are distinct. Distinct means I don't have 2 or 5 here in the prime factors of 21. They are distinct. So I pick all of them and multiply. So 2 times 5 times 3 times 7. That gives what? 210. That gives 210. That is how we get to this LCM. If you don't want that, just do the multiples. Okay, just do the multiples. Sometimes, okay, sometimes the LCM is just the multiplication of the two numbers. Like this 21. The LCM is just 10 times 21, 210. When you do it with the multiples, you are going to get a long one because you're not going to get a lowest common multiple till you get to 210. 210 is the lowest common between them. All right. Now, if we decide to look at some of these worked examples, problem 11. So here, pretty much, I'm going to skip 11 and then we'll go to 12. Now it says find the LCD. The LCD of x minus 1, LCM of x minus 1 and x plus 1. We just multiply them together, right? Because here that gives you the lowest common multiple. You multiply them together. Okay, kind of like problem 11 because I know it's the same thing. That's why I skipped that. X and then x plus 1. Okay, you multiply them. Now, what about problem 13? Problem 13. So find the LCM of x squared minus 9 and x plus 3, the lowest common multiple. So here, if you look at x squared minus 9, this is a difference of 2 squares, which we know that is equal to that. So you can say that these two numbers, x plus 3, x minus, let me x minus, there should be a minus 3, minus 3. Okay. Now, what about x plus 3? And that just gives you x plus 3, right? Because you still have the same thing. So what is the lowest common multiple of this? Kind of like you have, let me show you this, the LCM of 6 and 3. You know that 6 is a multiple of 3, right? 6 is a multiple of 3. So if you are finding LCM of 6 and 3, we know that because 6 is a multiple of 3, you know that the LCM is going to be 6. Why? Because if you go to 6 and you do this, you have 6, 12, 18, and then it keeps going, 24, and then it keeps going like that. Now for 3, you have 3, 6, 9, 12, and then it keeps going like that. So you have 6 here, you have 6 here. Okay. So 6 becomes the lowest common multiple. Now again, if you think about it, 6 and 3. 6 can be equal to 2 times 3, right? So you would see that, oh, okay, 3 is right here. 3 is a multiple. 6 is a multiple of 3. So you know that the LCM is going to be 6. Now when you come here, because you have this, just like we did 2 times 3 here, you have x plus 3, x minus 3. And x plus 3 is in that. So x squared minus 9 is kind of like a multiple of x plus 3. So the LCM is going to be what? X squared minus 9, which is this x squared plus 3, x minus 3, right? That's difference between two squares. So that becomes our LCM. That becomes our LCM. All right. Now, adding two fractions. Adding two fractions. This I know some of you still remember, some of you have forgotten. So we are going to go through that. So we have 5 over 6 plus 3 over 7. Now I know that if I have 2 over 4, oops, 2 over 4, let me erase that. 2 over 4 plus 5 over 4. Because I have the same denominators, I only add the numerators. 2 plus 5 is 7 over 4. So always when you're adding fractions, if you have the same denominator, it makes your life easier, right? You only add the numerators. The denominator stays the same. So if I have 5 over 6 plus 3 over 7, how do I change the denominators to be the same denominators and then add them? I have to find the LCM. The LCM of 6 and 7 is 42. It's 42. Or the LCD this time because we are looking at the denominator. It's is 42. So if I have 42, then I could pick each of these fractions, 5 over 6, and then because I want to change the denominator to 42, I multiply this by 7 over 7. Why am I multiplying by 7 over 7? Because this would help me get 42 from the bottom. I want to change the fraction. That is multiplied by 7 over 7. 7 over 7 is 1 because it cancels out, right? 7 over 7 cancels out. 1, 1. So I'm only multiplying by 1, right? But because I need a denominator of 42, I chose 7. So 7 over 7. That gives me 35 over 42. And then what about this guy? 3 over 7. Because I want a denominator of 42, I want the same denominator. I multiply by 6 over 6. That gives me 18 over 42. So that brings me here. 35 over 42 plus 18 over 42. You just add the numerators and then the denominator stays the same. Yes. Okay. Now with that analogy, let's look at this. We are adding these two. We're adding these two. So to add them, we have 5 over 6x plus 3 over 7. Now here, the LCD is 6x times 7, which is 42x. 42x. So to get the same denominator here, I do 5 over 6x times 7 times 7. This gives 35 over 42x. And then for 3 over 7, I have times 6x times 6x. Because I want to get the same denominator. 18x over 42 what? X. Okay, so I'm going to have this guy here, and then that. You add them together. So I have 35 over 42x plus 18x over 42x. So that gives us 35 plus 18x, oops, plus 18x divided by 42x. So 35 plus 18x divided by 42x. And that's what you have. Okay. Now, what about subtraction? Subtraction. So we are subtracting f of x minus that. Again, we want to get the same denominators because it makes life easy for us. So we've got two denominators, 3x and then 8. The LCD, you multiply them together, you have 24x. 24x. So 2 over 3x times 8 over 8. 16 over 24x. 3x over 8 times what? 3x times 3x. This gives 9x squared over 24x. Okay, so I've got this, which is my f of x minus that. So that in all is going to give me 16 over 24x minus 9x squared over what? 24x. And the denominator stays the same. I only work on that minus 9x squared. Now the top will give me a difference between two squares, right? Because 16 is 4 squared. So this can give me 4 squared minus 3 all squared divided by 24x, right? Because we've got 9x squared, so 3x. Again, check to make sure you're right. Check to make sure you're right. And the top, that is the difference between two squares, is going to give me this. 4 minus 3x times 4 plus 3x, all divided by 24x. And that's it. That's all you do. That's all you do. Difference between two squares. If you forgot about that, please go back and then look at it. All right. So here, problem 17, we've got 3 over 5x plus 5x over 3. So if you do this, you have to multiply this by 3 over 3, we get 9 over 15x. And then 5x over 3 multiplied by what? 5x over 5x. And that gives you 25x squared over 15x. So I've got this here, I've got that here. So f of x minus that. Oh, it's adding. It's adding. So we have 9 over 15x plus 25x squared over 15x. This equals 9 plus 25x squared over 15x. Yep, and that's it. All right. Let's keep going. What about problem 18? That is a media example, so I'm not going to worry about that. Problem 19 is a media example. Please go back and then watch those. Please go back and then watch those. Okay? All right. Now, problem 20. Problem 20. Here, let's look at this really, really well. I've got 3 over x minus x over x minus 1. So again, here we've got to take our time doing this. We got to take our time. Now, remember we talked about, look at the denominators, we talked about that. So x and then x minus 1 will be x times x minus 1 for the denominator. So 3 over x minus x over x minus 1. This is going to be, okay, now since we've got x and then x minus 1 as the denominator, again, you could either multiply x by x minus 1 and multiply x minus 1 by x. So this, let me go to the whiteboard. I think the whiteboard would help. 3 over x minus x over x minus 1. So here we could do 3 over x times this guy. Again, x minus 1 divided by x minus 1 is 1, right? Minus x over x minus 1 times what? X over x times this guy, so that we get the same denominator. So 3 times x minus 1, you have 3 x minus 1 over x minus 1 minus x times x is x squared, x minus 1. So we are still going to get the same denominator. So this will be equal to x minus 1. Then we have 3x minus 1 minus x squared. Now, we can work on this a little bit because I think we are going to get a quadratic at some point. So we can work on that a little bit. How do we do that? Let's look at that quickly. So 3 times x is 3x. 3 times minus 1 is minus 3. So we are going to have 3x minus 3, and then we've got this guy minus x squared. Okay, so this here will be equal to, let me start with the minus x squared because I'm just rearranging them, plus 3x, okay, minus 3. It's minus 1. Right? So, since we have this at this point, we try to see if we can get some factorization done, if possible. Okay, and then if it's not possible, you just leave it as it is. Just leave it alone. You don't worry about it again. You don't worry about it again. So with this function, minus x squared plus 3x minus 3. If you want to factorize that, is it possible to factorize it? That is a question. If it's not possible, then we don't worry about it. But if it's possible, then we have to work on it. If it's possible, then we have to work on it. If it's not possible, then you leave it as it is. That's how this works. So we've got minus 1 here and then minus 3. So minus 1 times minus 3 is 3. So we look for 2 numbers that would multiply to give you that. Then we look for 2 numbers that would add to give you the 3x, that is the 3. Is there a number like that? No, there is not. So this, you leave it as it is, like that. Okay, leave it like that. All right, let's keep going. Let's keep going. Oops. All right, so problem 21 is a worked example. But I would say that let's look at it. Let's look at it. So here we have minus 2 divided by x squared minus x plus 5. So x squared minus x plus 5 is a quadratic. And then we have 5 over x minus 1. We are adding them together. So we have, right? We are adding them together. Now, x squared minus 6x plus 5, you could factorize that, right? If you do that, you would have this, x minus 5, x minus 1. We know how to do that, right? You do the AC method, okay, where a is what? 1. So you do that, and then you have that. So you have kind of minus 2 divided by this, x minus 5, x plus x minus 1, plus 5 over x minus 1. Okay? So when you get to this point, then you know that it's about the LCD and finding the same denominator and adding them together. So in doing that, to get the same denominator, you know that you have x minus 1 here, x minus 1 here, and then in the LCD, or expanding this, you have this, x minus 5, x minus 1. So you have x minus 5 in this, that is this guy, in that. So to get the same denominator, this can stay the same, and then you only multiply this by x minus 5. So that is what is happening here. So we multiply the top and bottom by x minus 5. Why? So that we get this denominator, which is the same as the denominator for that. So you're going to get this when you multiply x minus 5 divided by x minus 5 by that. So that gives us this. So in the end, we have the same denominators, and then you add the numerators, Okay, so when you add the numerators, you have minus 2 plus 5x minus 5, and then you could open this up, minus 2 plus 5x minus 25. So minus 2 minus 25, minus minus gives you more minus, right? So you have 5 minus 5x minus 27. That's how we got this. And the same denominator. This is not difficult, okay? It's not difficult. All about you getting the understanding. Oh, what about this worked example? You've got 3x plus negative 7 over what? X. Okay. Now, the LCD here, x and x, so that helps us. We have x, right? So you're going to have 3 plus and minus. Positive times negative is negative 7. So you have negative 4 over x. That's it. That's right here. Okay. What about if you are subtracting? What about if you are subtracting? I'm going to erase this. What about if you are subtracting? You have 3 over x minus 7 over x, or something like this. You could put that in parentheses. So 3 here, because it's got the same denominator. Minus times minus is positive, so we have 10 over x. That. Okay. Now, what about if you are multiplying? When you're multiplying, you have 3. Oops. So 3 times, so you multiply the top, right? And then you multiply the bottom. 3 times negative 7 is negative 21 over x squared. Yep. All right. Now, what about if you are dividing? What about if you are dividing? So when you are dividing, again, remember the rules. 3 over x divided by negative 7 over x. The rule says you have to change the sign. The divide changes to what? Multiply. And then you flip this over, you reciprocate this. So you flip it over, we're going to have x over negative 7. 3 times x is 3x, right? Over negative 7x. So x will cancel x. So we have negative 3 over 7. But the negative is going to affect the whole thing. So you bring it on top. Negative 3 over 7. Okay. All right. So we have a U-try problem with problem 23. Problem 23. So we are going to do 23 and then we move on. So we have 1 over x plus negative 4x plus 1 over x. Okay. So what is this going to give us? You could try this before I do it. You could pause the video and then try it and see if you get it right or not. This is a little tricky, but try it and see if you get it or not. So here you have negative 4x plus 1. This is like having x being the same denominator, 1. Now, this negative 4x, remember, it doesn't affect the whole thing. That's why it's set up this way. Because negative 4x plus 1 here can be written as 1 minus 4x. It's the same thing. Okay? So the negative doesn't affect the whole thing. So we could do 1 minus 4x plus 1. So 1 plus 1 gives a 2 as grouping like terms. Right? 1 plus 1 gives a 2. So we have 2 minus 4x over x, like that. So that becomes our final answer. Or you could factorize this. You get 2 out, 1 minus 4x, like that. Oh, 1 minus 2x, sorry. 1 minus 2x. Sorry about that. 1 minus 2x. Okay? Now, what about when you're subtracting them? So we have 1 minus x minus 4x plus 1. Now at this point, remember this minus is there, this minus is there, so you have 1 over x. So minus times minus 4. Okay, or let me move on this way. So we have x, so we have 1 from here, from this guy. Minus times minus 4 is positive 4x. minus, because this is like putting this in a parenthesis, right? You already have a minus here. Okay, so minus 4 is positive. Negative times positive 1 is negative 1. So 1 minus 1, like times is 0. You have 4x over x, which gives you a 4. Like that, it gives you a 4. Now, what about if you are multiplying them? What about if you are multiplying them? So multiplying them, we got 1 over x times negative 4x plus 1 over x. So 1 times any number is that same thing, times anything is the same thing. So we have negative 4x plus 1 over x times x is x squared. Yeah. So that was an easy one. Okay. What about dividing? What about dividing when you're dividing? When you're dividing. So when you're dividing, you are going to have 1 over x divided by negative 4x plus 1 over x. So 1 over x, to change the sign, times. You flip this over, negative 4x plus 1. So 1 times x is x. This times that is going to give you x times negative 4x plus 1. So x will cancel x. So that gives me 1 over negative 4x plus 1. Remember, you could rewrite this as 1 over 1 minus 4x. That makes anybody feels more comfortable, right? Because the negative sometimes confuses a lot of students. All right. So we are not going to do 24 because you should be able to do that one. Then what about 25? 26, we keep going like that. So with what we've done so far, you should be able to do all these ones. Okay, should be able to do all these ones. So try some of these, and then I think you should be able to get them right. So what I'm going to do is that I'm going to give you the answer to all of these, okay, so that it makes your work easier, because I think some of the students sent me messages about answers to some of these. So here I would say that because we've got f of x plus g of x, you should at the end get this. Because here you have x and 5 as a denominator, remember you have to do 1 over x times 5 over 5. And that gives you 5 over what? 5x. And then what about negative 4x over 5? That you do x times x, so that you get the same denominators, right? So negative 4x times x gives you negative 4x squared over 5x. So I have the same denominators, 5x, 5x. So I'm adding, so I only add what? The numerator. So I have 5 minus 4x squared over what? 5x, like that. Okay? Why? Because I'm adding. And positive times negative is still negative, so it doesn't matter. Right? Positive times negative is still negative. So if you are subtracting, remember it's still going to be the same fractions, right? The same fractions, and then you subtract. So what is the answer going to be? So here we have 4, because we are adding, we have 5 minus 4x squared over 5x. Wow. 5, and then here we're going to have 5 plus 4x squared over 5x, because negative times negative will give you a positive. So these are the answers to this one. Okay. And then what about when we are multiplying? We are multiplying. You have 1 over x times negative 4x over 5. So the x would cancel. So we have negative 4 over 5. Okay. Or you multiply them and after you cancel the x. What about division? Division, you should get negative 5 over 4x squared, like that. That's what you should get for your answers for that one. Now, what about this next one? It's a you try problem. It's a you try problem. So here again, you have to make sure that you have the same denominators. So x plus 3, x plus 1. This you're going to get 6 over 6. You multiply by 6 over 6, which gives you 6x plus 3. 6x plus 1, right? And then for the next one, 5 over 6. You multiply by what? X plus 1, x plus 1. Why are we doing that? To get the same denominator. So 5x plus 1, 6x plus 1. So you add them, you subtract them, and you do all that, okay? So add and subtract, you do that. For multiplication and division, you don't worry about, changing these fractions to similar fractions. You don't worry about that, you just multiply. Because for multiplication, you know that you're just multiplying that. So you have, for multiplication, you're going to have 5 times x plus 3 divided by 6 times x plus 1. That's it. You could expand it. You could expand it. 5 times x, 5 times 3, right? You could expand that. So let me give you the answers to these, and then we move on. So here you're going to have x plus 13 over x, 6x plus 1. For no, that's for subtraction. So for addition, you're going to have 11x plus 23 over 6x plus 1. And then here you're going to have x plus 13 over 6x plus 1. Like that. Okay? All right. So if you're not getting that, then it means there is a problem with what you are doing. Here I already did this. You have 5x plus 3 over 6x plus 1. With this one, get 6x plus 3, 5x plus 1. That's what you're going to get. Okay? And then what about these ones? So here, if you add these, you are going to get x squared plus 4 divided by x minus 2, x plus 2. And then for this one, we're going to get minus x squared plus 4x plus 4 divided by x minus 2, x plus 2. That's what you should get for this. Okay? And then for the multiplication is easier, right? So 2x over Now, for division, you're going to get 2 over like that. And then here you are adding 1 plus that. So here, because it's 1, you still have to make sure that you get the LCD. So 1 over 1, you could change that to by multiplying x plus 4, x plus 4. Okay? So 1 becomes x plus 4, x plus 4. So now you've got the same denominator, so you add them. All right? So you add them. Maybe you could do the addition and then do the subtraction by yourself. So x squared minus 6x over x plus 4 plus x plus 4 over x plus 4. You see that? So you're going to have x squared minus 6x plus x plus 4 over x plus 4, right? Same denominator. So this guy, minus 6x plus x, gives you what? X squared is 5x plus 4. Okay. Now, if you factorize this with the AC method, where a is 1, you're going to have x plus 4 here, and then you're going to have x minus 1, x minus 4. So that's what you get in the end, okay? That's what you get. So you do the same for subtraction, where it's the same thing, only that this changes to what? Subtraction. This changes to subtraction. This changes to subtraction. Okay. So for subtraction, in the end, you're going to have x yes, you're going to have this. For multiplication, you're going to have x squared minus 6x over x minus, x plus 4, sorry, which is x minus 6 over x plus 4, like that. Okay. All right. Why? Because you're just multiplying by 1, because you get the same thing in the end. You are just multiplying by 1, right? And then divide by 1 is the same thing, right? Anything divided by 1 is that thing itself, right? Anything multiplied by 1 is that thing itself. So that is an easy one. Okay, we did something like this, so I'm going to skip this one. And then now we are at the point where we are looking at graphing and then solving this algebraically. But I'm going to end this video here, and then we'll look at that later. Thank you.